Um, Thank you all for coming to our icebreaker event, a little bit different than usual, but I hope that you're all sitting with your glasses of wine or beer and have some food and are ready to go. I have a couple of opening remarks I'd like to make, but part of the reason for the opening remarks is to give everybody a chance to think about introducing themselves after that. It doesn't have to be long, just your name, and if you're in particular, if you're a new student, because we're obviously very interested in talking to the new students. If you're a new student, just tell us where you came from. If you have been here for a while, just tell us a little bit about what you're doing. I'll go down through the participant scrolling, and I'm just basically going to call people's names off as I see them on here. But while you're thinking about your very short introduction, let me just introduce our icebreaker. Obviously, a different format than usual. With any luck at all, we'll be back to the usual format next fall. And that, of course, introduces COVID-19. COVID-19 has created a dramatic change, obviously, for all of us. And it will obviously eventually go away, and it'll float into history with all of the other pandemics, but it obviously has very severe consequences now. We have a lot of other things going on. We obviously have all sorts of politics going on, and we have economic issues and unemployment, geopolitical issues, a variety of things. But if we just look right now at climate change and COVID-19, there are, of course, some interesting things to learn. COVID-19 is terrible. It's a disaster for all of us, for many of us, much more than a disaster. But at the same time, it's taught us that we can do with a lot less. It's showed us that, in fact, you can clean the atmosphere up quite quickly and see the stars at night, which we normally, when I say we, I mean people all over the country and the world, normally wouldn't see. And unlike climate change, as I mentioned earlier, obviously we all know once a vaccine comes, this will go away. It'll fade into the past with great consequences nevertheless. Climate change, however, also can operate very fast, and it's not going to fade into the background. We are, as we all know, experiencing it significantly already. The consequences will become worse as time goes on. And I think it's very important for all of us in the Climate Change Institute to remember that when we think about climate, it's not just the physical, it's the chemical, it's the biological, it's the social aspects of all of these things. And when you think about climate in the broad, multi and interdisciplinary way that we do in the Climate Change Institute, you begin to realize how many things are touched by climate change. COVID-19 is one of them. We would, as a human race, do a lot better in our battle with COVID-19 if it weren't for climate change. We have food insecurity as a consequence of climate change. We have respiratory disease, cancers, heart disease, neurological diseases, and heat stress, and tremendous catastrophes such as the wildfires in the West, all as a consequence, not absolutely 100%, but significantly as a consequence of climate change. So as we begin to think about what we can all do for the future, I think it's important for us to realize that we really are in a remarkable position as climate scientists, whether we look at the chemical, the biological, the social, the physical aspects of climate change, to help think about mitigation, adaptation, and even more exciting in many ways are new ways of dealing in the future. We've been forced as a consequence of COVID-19 to meet in a very different way, to travel less. These are all things that we probably need to think about seriously if we want to mitigate and adapt to climate change. There are also great opportunities out there in the future. And while it's probably not a very PC thing to say that there are opportunities as a consequence of climate change, I don't mean that these are opportunities which would force us or engage us in having even worse climate change. There are opportunities because of the remarkable resilience of the human mind and our ability to find new ways to do things. The sort of things that we might have in the future might be better air quality as we begin to reduce greenhouses. We might become less dependent on oil and a variety of other things, most of which you're all very familiar with. So it's important as we listen to all the presentations today, as we listen to the students in their Bourne's presentations, to think about how all of these things come together and how we can use all of these to understand past and present climate change, which is something that our Institute has always done, and also to make better predictions for the future with respect to what the climate will be, what the impacts will be, and how, in fact, we will find better solutions for the future. So I think although this is in the midst of a terrible disaster, we really need to be very hopeful about the wake-up call that we've been given and the opportunities that we should can investigate because of the fact that our institute is in fact so multi and interdisciplinary. So I'll pause there. I'd like to go around through the introduction, and then I'd like to begin our tribute to the person who started our institute and was one of the first in the country to actually be thinking about multi and interdisciplinary activities. So Becky, you're first on the list here. Would you please introduce yourself? And before you do, thank you for putting the icebreaker together along with several others, including Dan Sandweiss and Betty.
Thank you. Hi, my name is Becky Adesi. I'm quote unquote in the main office. I guess right now I'm in my home office, but I have learned a lot this fall for sure about technology that I never ever dreamed I would. So you guys can bear with me on that. But we do have the Climate Change Institute YouTube channel under the University of Maine. So all of these events, Bournes and everything are being uploaded onto that so that students can go, or faculty or whoever can go and watch those. So I think that's just like a great silver lining to all of this, because we've always been trying to figure out how to record these things and get them out there. And this has provided us with a great opportunity to just record them on Zoom and put them out on the YouTube channel. So I've been working on that, which has been pretty easy after I learned it. So besides that, I've just been up to the regular office work that I've been doing. And so just email me if you need anything. I'll be happy to help you. Thank you.
And what could be better than binging climate change YouTube videos?
For sure.
Fantastic. George Jacobson, the third director of the Institute.
Yes, I'm George Jacobson. I'm a retired faculty member involved in paleoecology, plant ecology, and paleoclimatology, and I was director between George Denton and Paul. At the moment, I'm actually sitting in room 307. And I got kicked out of my own house because my wife is having a Zoom meeting there and we can't handle two in the same system. But I look forward to this and I appreciate being part of this evening.
Thank you. Aaron? Aaron, are you out there? I assume it's Aaron Putnam or Aaron Chesler. It's hard to tell.
Oh, you're talking to me?
Okay, yes, it's
Okay,
Aaron
yeah.
Chesler. Okay.
Hi. Sorry I'm a little late, got caught in a quick meeting, but my name's Aaron Chesler. I work with Carl and Aaron Putnam, which can be confusing at times. But I work on the South Pole Ice Core project looking at microparticles or dust microparticles and trace element geochemistry.
Thank you. Alessandro.
Hello everyone, I'm Alessandro. I'm a PhD student in Jacqueline's Gill Lab and I work on reconstructing the consequences of megafaunal extinction in Beringia.
Thank you. Alex, I assume that's Alex Moore.
I assume you're right. My name is Alex Moore. I work with Paul and Andre on the Colony Feti project, and Becky said that I could show you some things that we could all be proud of. So I'll just show you. Oh, no, I can't show you anything because I'm disabled. So I'm just going to tell you that I work on the impact of climate change on people's health and the economy and people's impact on climate and the environment, both now and in history. We just published about 10 days ago an article in an AGU journal called GeoHealth, which has since gone viral. CNN, Washington Post, and everybody and their brother then after that picked it up. And it's all about connecting the pandemic to climate change, as Paul was suggesting. And that's really all I do.
Thank you. Alice Kelly.
Alice Kelly, Earth and Climate Sciences, as well as the Climate Change Institute. And I am interested in geoarchaeology. You'll hear more about that. And I work closely with Dan Sandweiss and Bonnie Newsom.
Thank you. Andre.
Andrei Krubatov. I have dual appointment, Climate Change Institute and School of Earth and Climate Sciences. I work with tephra particles in polar ice cores. I also work with pretty much with a lot of people at the Institute. I think you'll hear that later. And my main kind of sort of part in the research was related to old ice. And also I work with Colin Ifeti project. We do some adaptation of technology, I guess, for data mining, things like this. So that's pretty much it.
Okay. Bonnie, we're going to hear 2 minutes from many of these people as we go on. Bonnie?
Hello, my name's Bonnie Newsom. I'm a member of the anthropology department and the Climate Change Institute, and I'm an archaeologist specializing in Maine archaeology.
Thank you. Ciao.
I am Sudarshan Chawate. I go by Chow. I'm a computer scientist and I work primarily on data management and related algorithms.
Thank you. Christoph. Christoph, are you out there? No. Okay. Cindy, please.
Hey, everybody. Nice to see you all. I'm Cindy Eisenhower. I have a joint appointment in the Department of Anthropology and in the Climate Change Institute. I'm a cultural anthropologist focused on environmental policy and climate policy.
Thank you. Dan Sandweiss.
Hi, I'm Dan. You've already heard me a bit. You'll hear more about me later on. I'm an archaeologist in anthropology and climate change, and I've been here for almost 28 years.
And you must be the bartender too.
Absolutely. Got to be in the right place for these kind of events.
Very
As
good.
close as I could get to being in the Penobscot.
Excellent, excellent.
DC.
Dan Dixon.
Hello. I'm Dan Dixon, research assistant professor at Climate Change Institute, working on ice cores and drilling and stuff. I'm also the director of sustainability for the UMaine campus.
Thank you. Dom.
Hi, everyone. I'm Dom Winsky. I'm a research assistant professor here at the Climate Change Institute. Sorry, I'm realizing that my room is very dark, but you'll hear from me more in a few minutes about the ice core research that I do. Thanks.
Thank you. Elizabeth Leclerc.
Hi, I'm Elizabeth Leclerc. I'm a second-year graduate student in CCI and the anthropology department.
Thank you. Emma Irwin.
Hi, I'm a first-year graduate student. I'm working with Seth Campbell and working on modeling ice core sites up in Alaska.
Thank you. Jim Fastook.
Hi, I have a joint appointment in CCI and computer science, and I do ice sheet modeling, primarily on Mars these days, but I have worked on paleo and current ice sheets as well.
Thank you. Welcome back from Mars. George Denton, the second director of the Institute. I think you have to unmute, George.
Sorry about that. My name is George Denton. I have a joint appointment in the CCI and Earth Sciences, and I work on glaciers and ice sheets and their relationship to climate.
Thank you. Heather.
Everyone, I'm Heather Clifford. I'm a PhD student. I work with Paul Mayevsky and Andrei Kurbatov. I mainly work on ice cores in high mountain regions.
Thank you. Ingelise.
Hi, I'm Inga. I'm a second year master's student. I work with Carl Kreutz and Tom Winsky on ice cores up from Alaska and the Yukon.
Thank you. Ivan.
Hi, I'm Ivan Fernandez in the School of Forest Resources, Climate Change Institute, and the School of Food and Agriculture. I'm a soil scientist.
Thank you. Jasmine, Associate Director of the Institute.
Hi, I'm Jasmine Saros. I am a professor of paleolimnology in the biology department, and as Paul said, Associate Director of CCI.
Thank you. Katie Glover.
Hi, everyone. I'm Katie Glover. I'm a research associate and instructor at CCI. I largely look at past glacial ecosystems in North America and talk about interdisciplinary. I'm an instructor for ecology, data science, gender issues and climate change, among other things.
Thank you. Kimberly.
Hi, everyone. I'm Kimberly Miner. I'm a research assistant professor here. Also got brought up through CCI. I'll talk a little bit about that. I look at climate change risk, and I mainly focus on the Arctic.
Thank you. Kirk.
Hi, I'm Kirk Mosh. I'm a professor in the School of Earth and Climate Sciences and the Climate Change Institute, and I study climate change and atmospheric science.
Thank you. Lizzie.
Hello, everyone. I'm Lizzie Gadrani, first year graduate student from Georgia. I'm working with Paul Mayevsky and Andrei Kurbatov. I study paleoclimate reconstruction and will analyze ice cores from Allan Hills Blue Ice Area, Antarctica. Thank you.
Thank you. Mario.
Hi, everyone. My name is Mario Potocki. I'm Paul's PhD student. I'm working on ice cores from Antarctica, Andes, and recently ice cores from Himalayas. Thank you.
Thank you. Madeline.
Hi, I'm Madeline Landrum. I haven't actually started yet. I start in spring 2021, and I'll be a first-year graduate student working with Dr. Jacqueline Gill on Indigenous people's use of fire pre-contact in Maine.
You're good for you. You're starting early. That's wonderful. Mark Royer.
Hi, I'm Mark Royer. I'm a computer science PhD student. I work with Andre and Chaw and help with developing software for managing ice core data.
Thank you. Meredith.
Hi, I'm Meredith. I'm a master's student in Earth and Climate Science, and I work with Andrei Kurbatov on ice cores and volcanic ash at the South Pole.
Thank you. Nicholas.
Hi, I'm Nick Whiteman. I'm working with Peter Coons doing hydrodynamics for coastal erosion and aerodynamics for COVID exposure.
Thank you. Paloma.
Hi, I'm a first-year master's student in marine policy and the climate change certificate, and I'm working on climate change vulnerability in small-scale fisheries in the U.S.
Thank you. Peter Coons.
Yeah, I'm professor of geodynamics in the Earth and Climate Sciences and CCI, and I work on the interaction systems from the mantle to the stratosphere.
Thank you. Roger Hook. Okay, maybe Roger's not there right now. Scott Braddock.
Hello all, I'm a third year PhD student working with Seth Campbell, looking at radar stratigraphy in the West Atlantic ice sheet. And I also work with Brenda Hall on the International Glacier Collaboration on our end.
Thank you. Sean Burkle.
Hi, everyone. Sean Burkle, I'm research assistant professor and the Maine State climatologist.
with CCI and a joint appointment in earth sciences. And I'm interested in main climatology, climate variability, and climate modeling. And I'll share more with you later. Thank you.
Thank you. Scott Braddock? I guess
Okay,
you already did that. Steve Norton.
I'm Steve Norton. I'm a retired environmental geochemist, and my environments range in age from late glacial to the present.
Thank you, Steve. Did I leave anybody out? If I did, just please chime in.
Yep, I can go, Paul. This is
Okay.
Seth
Oh,
Campbell.
sorry. I saw you before, but I missed. The names jump all over here. Seth.
That's okay. No worries. Seth Campbell. I'm an assistant professor in Earth and Climate Sciences and CCI, jointly appointed, and I work on glaciology topics, permafrost topics, and near-surface geophysics topics.
Thank you. Anybody else out there?
Mark
I'm Kristen.
Jordan. Yeah.
Sorry. Peter, you can go.
Kristen, go ahead, please.
Okay. All right. Sorry I'm late. I just finished my lab. I'm Kristen Schild. I study ice-ocean interactions. I'm a research assistant professor here, and I'll talk more soon.
Thank you. Anybody else that just came in or that we missed?
I just came in a little bit late as well from another meeting. I'm Greg Zaro. I'm the Associate Professor of Anthropology and Chair of Anthropology. I'm an archaeologist and study urbanization and landscape change.
You're also interim chair of classics, aren't you?
Modern languages and classics, yes.
Okay. Anybody else out there, please?
Mark Jordan. I'm a PhD student with Peter Coons, studying fluid-solid interactions.
Thank you, Mark. Anybody else? Okay, great. Well, welcome all. Obviously, this is our icebreaker session. The purpose of this icebreaker is to get some brief remarks from primarily the research from the faculty. And the purpose for that is for all of us to learn what we're doing. We're a pretty dynamic group. We're always doing new things, always continuing our old projects too. And obviously for the students out there who may or may not realize who's involved in the Institute and what's actually going on. So the icebreaker is one of our meetings. The other meeting that we have is the Bourne Symposium. And the Bourne Symposium typically goes on over 2 days in the spring. Because of COVID-19, we postponed it to this fall. And of course, as you all know, I hope, it's now being offered once a week, 12 to 1 on Mondays, and it'll probably go throughout, it will go throughout this entire semester and potentially the next semester. And that's an excellent way to begin talking about Hal Bournes. Professor Harold W. Bournes Jr. passed away this spring. He was the founder of our institute. The name was different at that time. It was the Institute for Quaternary Studies. A remarkable man who touched many of us, and several of us will be talking about him. We're going to have a much more significant tribute for Hal in 2021, in the expectation that we can actually all get together. And most likely, along with our 50th anniversary of the Institute. It couldn't be a more fitting situation than to give tribute to Hal as a consequence of our 50th anniversary. It's unfortunate that he couldn't be with us. Hal had a very diverse background. We have a piece on the website, on the CCI website, that describes his background to some degree. He served in the US Coast Guard during World War II. After that, he worked for Bell Telephone. After that, he went to college, wanted to be an electrical engineer, but discovered geology, his passion. And as we all know, I'm sure we've all been directed to where we are right now by our passion. It's an absolutely essential component of humans who are trying to understand what they're doing and what's going on around them. He went through college as geologist, into graduate school, and then ended up meeting up with George Denton, who then was an undergraduate. And the two of them together, along with several other people, including the professor that I worked under and as an undergraduate, Parker Calkin, who passed away a couple of years ago, they were involved in what was called the International Geophysical Year. It ran from 1957 to 1958. 59, I believe they were in the second year of it. And those two, the first and second directors of our institute, you can see their picture while they were from their time in the field in both Sawyer and Bryan. After that, Hal started his position as professor in geology at the University of Maine, where he stayed throughout his entire career, working extensively on glacial geology, his passion, in Antarctica, in Europe, obviously in Maine. And you can't help but think that one of the reasons why Hal spearheaded the idea of an institute like ours was because he had so much experience. He'd been in the military, he'd worked in industry, he had traveled a great deal. And I think one good way of describing Hal was that he was very open-minded, very flexible, and I believe it was because of all those experiences that he had and the fact that he understood passion for doing something and the fact that many other people had that passion. The time that he spearheaded the start of the Institute for Quaternary Studies, the idea of a much less an interdisciplinary institute was very uncommon. But nevertheless, he started that along with several other people. Some of the earliest are with us. Obviously, George Denton, Steve Norton, George Jacobson, Kirk Mosh later on, Dan Sennweiss, and many others. The institute that he started has survived for almost 50 years, unlike many other research institutes because of the way he started. He went around, got advice from the National Academy of Sciences, from many other places that had institutes, and realized that it was essential for a research institute to have very strong ties to academic units, which in fact we do, several academic units in our university and well beyond in other research institutes too. Hal leaves us with a very amazing legacy of good humor, open-mindedness, flexibility, passion, the idea that we should be collaborating, cooperating, and that we can do things better if we do them together. He also leaves behind in his legacy the Ice Age Main Trail, which has gotten to be extremely popular. It's now available, as is everything else, in the form of a smartphone app, and you can walk along the former margins of the ice sheet in Maine and learn a great deal as a consequence. He also started in the final years the Virtual Polar Research Center, which will hold his collections and collections from several other prominent Antarctic people in our university, in addition to collections donated because people knew Hal, because they knew that he wanted to preserve this legacy, which is very important to our institute, our polar legacy, our globally distributed research legacy, our open-mindedness, our passion, and all of those things. So I got to meet Hal in between graduating from college, not the University of Maine, another one, and going to graduate school, not the University of Maine, but another one. And then after that, I ended up as a postdoc with George Denton, and I worked with Hal at that time too. So I'm very excited, more than excited. I'm very honored and very thankful that I was given the opportunity to come back in 2000, and much of that had to do with Hal, his openness, his friendliness. So we have three other people who are going to speak briefly about Hal. The second is Dan Sennweiss, followed by George Jacobson and George Denton. So Dan, if you would take over, please.
Yeah, thanks, Paul. It's a real pleasure to be able to talk about Hal. It's also kind of nice to be the youngest person in a group of speakers. It's been a while since that's happened. So thank you, Paul, George, and George, for that opportunity. Hal was the ideal senior colleague. He was, I guess, about 30 years, maybe more older than I am. When I got here, He took me under his wing immediately. Within 6 months, he had taken me to Washington to meet program managers at NSF, where he had recently been a program manager, so he knew them. On one occasion, he said, we need to do this research together. I'll apply for a faculty research grant so we can go down and do it. I did it. I didn't get it, I think, because I'd had one 2 years before. And he said, well, this isn't right. And he marched me down to the VPR's office, and we sat there, and he said, it was Dan Dwyer. I said, Dan, you need to give us this money. You just have to do it. And he wouldn't leave until we got $5,000 and went on this expedition. And at the time, he was in his 70s, upper 70s. He had atrial fibrillation. We were staying at 3,800 meters above sea level with no heat and virtually no hot water. We went up much higher. He was at least as good in the field as I was, and as strong and as effective. We went up one day to 4,600 and walked around for a couple of hours, and it was like nothing for him. And he had great ideas about it. He connected to doing some very early cosmogenic dating. This was 1998 when it was really quite new. He knew somebody who did it, and he got some samples run for us. It was really, really remarkable working with Hal. At one point, he had seen an article about the discovery of stone points in one of the bays of the South Shetland Islands. Said, we should go down and see if there's archaeology there. We did. We tried. We applied to NSF grants. We applied twice. We got very good reviews. They all said, this is a great project, really well put together, but we don't think there's anything there. So we never did end up doing it. But he always had great ideas, and he always wanted to share and help. And I think that's part of how he made the Institute work the way that it does, is this constant desire to collaborate, to work together, to cross boundaries, and to find new and better ways to do things. And I'll pass it on to George.
Okay, thank you. Well, I was one of the early faculty members hired after the Institute was organized and put together, and I came here in 1979. Hal, as everybody knows, I suppose, was a very kind and generous and friendly person. He was extremely encouraging to young faculty members and students, and as Dan just implied, took very active interest in our work and our well-being as individuals. And he, for example, after I'd been here about 2 years, took me to Antarctica with him as a field assistant to the Allen Hills, where we'll hear about some research later on ongoing now. And he was, it wasn't, my own research didn't take me there, but he realized that my perspective on ice sheets and the glacial world would be enhanced if I had a chance to see that environment. And that, coupled with some research I'd been able to do as a graduate student, working up in the on some glaciers in the Yukon, set me up for understanding in a very personal way what the environments were like, and particularly in late glacial time, which is of course an important part of paleoecological studies. He always worked hard to cultivate early opportunities for group activities in our institute and interactions to build the personal relationships that allowed the interdisciplinary work to go on smoothly. We had quite regular meetings where we discussed not just administrative things, but science. There were seminars we would all attend, field trips that we took around Maine and the Northeast. Of course, many of them included gravel pits, but not all, because we went to lots of archaeological sites and other sites where quaternary research had been done. And those were very important for our institute, having a cohesiveness of individuals that cared about one another and each other's students. He also led in establishing and upholding very high standards for application during selective hiring procedures and critical promotion and tenure reviews. And that is always an important thing in building an academic or research unit, because that ultimately leads to strong, successful faculty and research group over many years. Paul mentioned that his belief in interdisciplinary research, Dan did as well. And one neat example was when he reached out to our colleague and historian, the late David C. Smith, back in the late 70s, when a British researcher named Hubert Lamb came to the university to give some seminars. Hubert Lamb was part of a research group at the University of East Anglia and had done a lot of research on what is known as climate history, that is historical records that can be applied. And that one interaction that Hal set up with Hubert Lamb brought Dave Smith into our institute and made him a central figure in a number of research projects and certainly collaborations as colleagues with many of us. By coincidence, Hubert Lamb helped to establish at the University of East Anglia a group called the Climatic Research Unit, and it was founded in the same year as our institute. Isn't that interesting? So here, the two of them were early, similar-minded scientists pulling together interdisciplinary research. He was very good at understanding how administrative leadership could succeed within the university. He was constantly educating the upper administration and making them insiders with respect to our research advances. And they always appreciated that greatly. And even more important, he always took responsibility for how our institute would uphold its obligations within the University of Maine's research system. The deal he had made is that if the university gave us support so we could have some salary support and places to serve as faculty, that our part of it would be to get research grants to support the research we were doing and to support the graduate students we had. And that was always the focus. He also kept an ongoing interest and focus in the development of the University of Maine as a research university itself. And he was the first University of Maine faculty member to get an NSF grant. He designed and led the first and most successful research unit on campus, ours. And at the very end of his life, he had an amazing meeting with our current president. If you'll bear with me for a moment, I'm going to bring up a photograph that I'd like you to see. Let's see here. No, hold on. Well, I don't know. Do you see me as the main screen here? It's not. I'm not the main screen on my own computer. But can somebody make me the main screen? Do you all see me as the main screen or not?
George, I think if you just move way off to the left or the right.
I will. So I'm turning
There we
this.
go.
Yeah, 'cause on my own screen, I don't see myself.
Right.
I'm just a tiny little, anyway, can you see now? This is a photo that I took at a meeting in last November between our president, Joan Farini Mundi, and Hal. And it's probably one of the last photographs taken of Hal, I'm sure. But Hal had written President Farini Mundi a letter some months before, a long letter describing his perspectives on research in the university and his experiences with the Institute. And she was really fascinated by that. And so we set up a meeting so the two of them could meet, and they were supposed to meet for an hour or so, but they talked for at least 90 minutes. Hal had about 5 pages of notes that he went through very specifically, and Joan was taking notes herself. And it was one of the most amazing and fun interactions to watch and be part of a little bit. And at the end, President Farini Mundi asked Hal, did he mind if she passed on his letter and the information he had just given her to NSF, because she happened to be going there the next week. As you all know, she was the second in command at NSF for a number of years and knew the director well. And she said that NSF amazingly had almost no archive of early historical information about itself. And so she saw this information from Hal as being really great for bringing in there. And sure enough, she did speak with the director of NSF the next week about Hal and his experiences. So, everything from Hal getting the first grant and being told he had to get his own bank account at a bank in Orono to put the money in because the university didn't do stuff like that. So, I mean, it's really a great series of stories. But I just wanted to end with that because I think that was a wonderful finish to Hal's career here, to be able to, in a way, pass on the information of his experience to our current president, who is a wonderful champion for research and helping to make us a much stronger research university every day. And with that, I'll pass it on to George Denton.
Oh, thank you, George. I just want to add a bit to what Paul and George said with three basic events that help mold Hal's approach. The first was that he had the full support in the 1960s of the geology department to develop a research interest in climate change, particularly paleoclimate change. That involved Phil Osberg, who at the time was chair of the department, Brad Hall, and perhaps most important, Steve Norton, who's still with us. It was because of their support that Hal felt confident in going ahead with trying to establish a group in paleoclimate research at the University of Maine. The second basic landmark was that Bob Nichols of Tufts University included Hal in an expedition to Antarctica in 1959-1960. And that's the trip that gave rise to the picture that's on the wall that Paul mentioned. This solidified Hal's knowledge and enthusiasm for paleoclimate research because he spent an entire season in the dry valleys of Antarctica, and he became more and more fascinated with paleoclimate, and Bob taught him a lot. The third major landmark was that following that trip to Antarctica, Hal took a sabbatical at Yale University, either in 1963 or 1964. And during that sabbatical, he studied under Richard Foster Flint and Link Washburn, who at the time were two of the leading paleoclimatologists in the world. And that solidified Hal's knowledge and his enthusiasm to move on from there and develop such a group at the University of Maine. But to my mind, those are the three major stepping stones that led to what we have today. The support of the original geology department, the support from Bob Nichols to get Hal into the field, and then the year at Yale, which he solidified his knowledge of paleoclimate.
Thank you, Dan, George Jacobson, and George Denton. I'm sure Hal would be really delighted to hear all of this, and we look forward to having an even bigger celebration in the future. I noticed, before I turn this over to Dan Sandweiss, I noticed that a couple of people have joined us, or a couple of people who may not have had an opportunity to introduce themselves. So please chime in if you weren't able to introduce yourself when we started.
Oh, go ahead. I'm Joe Kelly, and I am here with my wife in retirement, but enjoying everything.
Anybody else? We'll hear from Roger Hook as part of the presentations. Let me look down through here. I think, if I remember, Christoph.
I'm here now.
Oh, okay. Roger, please introduce yourself.
Can I go ahead?
Oh, okay, Christoph, please.
Turn off the phone first. Yeah, I'm Roger Hook. I'm a research professor in the School of Earth Sciences and Climate Change Institute. And I work on glaciers. Well, I used to work on glaciers. Now I work on mostly glacial geology and also the impact of humans on the environment.
Oops, sorry. Christoph, I muted myself. Would you introduce yourself, please?
Need to unmute.
Can you hear me?
Yes, now we can. Thank you.
Oh, okay. My name is Christophe. I'm a first year student, master's in anthropology, environment policy. So I'm working with Professor Greg.
Thank you. Welcome
Welcome. Yes.
welcome to the University of Maine and the Institute. Is there anybody else out there that we haven't heard from?
Yeah, I'm Ann Hill. I'm a second year master's student in the School of Earth and Climate Sciences, and I am working with Kristen Schild, and I'm studying surface changes on the McMurdo ice shelf.
Thank you. Anybody else?
Yeah, I'm Ian Nesbitt. I'm a third year master's student working with Seth Campbell, looking to do some sort of sediment volume studies in lakes in Maine. And I also went to Antarctica with a group to the Allen Hills to do radar work this past winter.
Great. Thank you. Anybody else we missed? No? Okay. Should we take maybe a quick 3-minute break if people need to get up and grab something? What time is it now? It is 5:49. Let's get back together at 5:55. And at that point, Dan Sandweiss will take over and we'll go through the presentations. Thank you so much, everybody. See you at 5:55.
The stage is yours.
Great. Thank you, Dan. Okay. Can you see my slides?
Not yet.
Oh, how about now?
Nope.
Oh, I see why. Okay. Apologies.
Yes, now we can.
Okay, great. Thanks. Well, hello again, everyone. I'm Sean Burkle, Research Assistant Professor, Maine State Climatologist. I'd like to share with you some of the work that I've been doing recently. On this first slide here, you can see a breakdown of various activities that I do. There's the climate-related research, and then in terms of data visualization and climate variability and modeling. But what I wanted to focus more on for the next couple minutes is an aspect of what I do as state climatologist. I'm trying to build up the Maine Climate Office as a resource for the public and stakeholders, where the public and stakeholders can access climate data, both in terms of monthly, annual, seasonal information about for precipitation, temperature, drought, and also daily scale information. And also, so in terms of that, I'm building the Maine Climate Office website that provides data access for both climate and weather data sets. I'm putting resources on the site that also have information from NOAA, in particular drought updates for the current event that's so far ongoing. And I'm also working with collaborators in cooperative extension, and we're interfacing with farmers and with the agricultural community, and in particular, building off from the work that I've done with Climate Reanalyzer, in which I've built a framework to access operational NOAA weather forecast models. I've begun taking those and developing a framework in which we can stream those for agriculture decision models. And I've been working with Glenn Kohler in cooperative extension, also Lily Calderwood. And with this, we call it AgEye Weather. This is a service that we currently have 100 sites across the East Coast. I don't have time to go into the history of that, but the long story short is one of the key goals that I hope to accomplish here is to provide weather data that's relevant to agriculture in the state of Maine that can help with decision making for farmers in different sectors. And thank you. And one last thing, if you for the students, if you have questions or data needs in terms of where to access and how to access climate data, please feel free to contact me. I'm happy to help. Thank you.
Thanks, Sean. Next up is Seth Campbell.
Thanks, Dan. Can everyone see this screen so far? All right, super. I'm Seth Campbell. As I mentioned earlier, I have a dual appointment at CCI and the Earth and Climate Sciences, and my expertise is primarily focused on cryosphere geophysics and looking at changes in the cryosphere. So that includes glaciers and permafrost environments primarily. I just found out I was going to be able to attend this about 10 or 15 minutes before the talks, before this came. So I just grabbed this poster. I'm going to scroll through some of the work that I do. My primary expertise is actually in ground penetrating radar and using radar to look at the subsurface of glaciers, permafrost, and near surface geology environments. And in particular, looking at how these environments are changing. So if you look in the upper left-hand side here of this slide, you can see this is actually what a radar profile looks like if we were to walk across a glacier. This is the bedrock. If you have this, the y-axis is time or depth, and then this is distance across, and you can see a bedrock horizon here. The ice is above it, and the ice gets about 600 meters in thickness here. And this is actually an ice course site that myself and colleagues, Carl Kreutz will probably mention this shortly, Dom Winsky, and others at the University of Maine are working on. So what we do is we take this type of information and we incorporate it into numerical models. We have surface elevation data and bed data. So this is a surface model here. This is a bed model here. We merge that together and we create a numerical model to look at ice flow dynamics at this site. And we try to use that for backing out details like accumulation rate and other variables that we might be interested in. So a lot of the times, a lot of the work that I do is kind of merging field observations with modeling. And we have a really strong modeling group here. I would say I'm the newbie, but others like Peter Coons certainly fits into that equation. So we have definitely a team effort going on. The other stuff that I work on as I scroll down here is really looking at coupled processes. And I mentioned coupled glacier processes here. This is a proposal that we've been trying to get funded here that I have a pretty strong suspicion it has a good chance next year, looking at some glacier systems in Alaska as it relates to glacier hydrology. So this is a little block model that one of our other faculty members, Kristen Schild, built. And it shows a little superglacial lake here, and we have a bunch of sensors that we're planning on deploying to kind of study the effect of this lake that drains every year in terms of how ice dynamics changes over time. And I'll scroll back up here to the right-hand side. The other processes that I look at are really large-scale processes. So we're thinking terrestrial environments to marine environments. And the three examples that I'm showing here, another figure from Kristen. She's quite a talented artist. So she put this figure together, and this was kind of a concept that Peter Coons, Sam Roy, myself, Kristen, and others devised about looking at terrestrial and marine processes from inland to coastal environments. And a lot of my work I work on is in Alaska. So we have this Juneau ice field, which I'll talk about shortly, to the Gulf of Alaska, and also Arctic permafrost towards the Arctic coast. And then, of course, New England is an environment that several of us are working on. And as I mentioned, I do a lot of field observations. So we're involved in a fair amount of drone type work, and then terrestrial measurements, and Kristen dives into oceanographic measurements. Upcoming in the next year or so, we're hoping to start doing more local scale studies of looking at snow change in different environments. One being the Pacific Northwest, so kind of coast of Alaska, and the other being in the Northeast of the US. This is actually a model built by Carrie Voyevich. She used to be a colleague of mine at my last place of employment, and now she's at NASA. And basically this model shows that the reds are areas where there's higher uncertainties in snow accumulation. So these two regions are areas that we're interested in studying. And the last thing I'll mention is a lot of the work that I do, I couple science education pretty closely with it. I direct the Juneau Icefield Research Program in Alaska and British Columbia every year. We have about 85 plus people that come to the Icefield every year, including 35 to 40 students. Although next year it looks like we might have upwards of 100 students due to some new program developments. So it's a great opportunity if as graduate students, undergraduate students that might have an interest in learning more about Earth system processes and cryosphere environments. Students spend 2 months on the ice field, traversing across the ice field. We also have a number of graduate students coming to the ice field to do research. So for any students interested in things like that, it's quite possible I can provide some opportunities at a relatively cheap cost to get you into the field. I think the one thing I graduated from UMaine, and I would say that UMaine is a phenomenal resource to get students into the field. So definitely reach out to me, reach out to other faculty if you're looking for field opportunities. And with that, I'll turn it over to someone else.
Thanks, Seth. Just remind everybody, we are trying to stick to 2 minutes per person because we have quite a long list and we will be here very late otherwise. Char, you're up next.
Oh, okay. I thought there was someone else before me. Okay, so so I'm just going to replace myself with my slides, and you guys can make my speaker view bigger or smaller as you wish, or make me just go away. Okay, so so I'm a computer scientist. I work on data mostly, and what I'd like to talk about today, just very briefly, is just a way of thinking about some of our work, focusing on what I call the data plumbing, and in particular on what might be clogging it. So, so we can think of the plumbing that goes into transforming the data that we might be working with. And I'm not going to really go through this list since I think most of us are quite familiar with many parts of it. It sort of starts with the early stages where the focus is on extracting the data, on archiving it, and so on. And well, and at the bottom, of course, we have all sorts of great stuff that we would like our data to give us. And the question is this pipeline running very smoothly, or is it running a bit slower than we would hope for? And in the latter case, where is the clog? And if we look at it, you know, some parts we know how to do very well. For example, archiving. There's many, many easy and cost-effective ways of doing that. And in fact, people fall over one another trying to get you to store your data with them. The data integration, not so much. And so what I'm going to sort of, my main point here is that data integration is one of the points where this data plumbing gets clogged. It's a hard problem. And there's a reason why we don't necessarily hear so much about it, because it's not something you can just throw money at to solve. Although if people throw money at me, I will certainly do a really good job of solving it. So people should feel free to do that. But my main point is it's a hard problem, but you can't just ignore it. And there's a lot of technology that's been developed in the past few decades that can be applied to it. So in summary, I would like you all to think of your data plumbing. And you know, unclogging plumbing is, as many of us might know, is not a particularly glamorous activity, but very, very essential. And I can perhaps help you. So with that, I will stop here.
Thank you. I think we all need to be unclogged. That's excellent. All right, next up is Dan Dixon.
Hello. Just going to share my screen. How's that? Can you see that? Excellent. So since graduating from the Climate Change Institute and Earth Sciences with my PhD in 2011, I've tried to remain involved in all aspects of ice core drilling and processing and general ice coring operations. My most recent foray in this respect is the design and fabrication of a thermal ice core drill, which you can see on the screen, which will help us to recover climate records from temperate glaciers, so glaciers that contain water all the way through. Impossible to drill with an electromechanical drill, so we're going to try and develop this thermal drill to collect our records. I've also been working on UMaine Sustainability, and I've been the Sustainability Director at UMaine since 2015. And I work with all levels within the campus: students, faculty, staff, administration, local community, and try and increase the sustainability of all of our operations. And I'm really focused on trying to reduce the environmental footprint of the campus. So I'm working on two big projects at the moment. One of them is a big project with facilities with the UMaine Energy team to completely revamp the central steam plant and try and switch our primary fuel from natural gas to a renewable fuel. The second project I'm working on is the design of the new life sciences building for NSFA. And we're going to try and turn that into a net zero, net energy, passive building if we can.
Thank you. All right, next is Jim Festook.
All right. There's always too much stuff on the screen. So my name is Jim Festook. I'm an ice sheet modeler. I wrote and maintained UMISM, the University of Maine ice sheet model. Lately, I've been mainly working on Mars with the idea of trying to justify a cold and wet early Mars as opposed to the warm and wet early Mars. And one of these deals with the idea that ice forms in the highlands and during certain transient events flows down through the canyons and forms the fluvial features. In addition, I've worked on Mercury. Glaciers on Mercury form in these permanently shadowed craters at the poles. The yellows are radar bright regions that are indicative of some kind of volatile, and they assume that it's water. This had to do a lot with some kind of amorphous ice, which is an ice that is sputtered as opposed to precipitated. And it's very soft, even at very cold temperatures. On Mars, I've done a little work with carbon dioxide glaciers, but I wanted to show you an ice stream on Pluto. This is the Sputnik plenum, which has a very clear ice stream flowing into it from the mountains around it. And anyone who remembers Terry Hughes's obsession with convection in the Antarctic ice sheet should be aware that the ice sheet on Pluto is clearly convecting. These are the convection cells, rising and falling cells. And while I was unable to get it in time, another scientist has used Terry's theory of convection in Antarctic ice sheets to back calculate properties of the Plutonian ice sheet, which is of course made of frozen nitrogen instead of water. So ice sheets on different planets. And I'll stop there.
Thanks, Jim. All right, next is Ivan Fernandez.
Okay, let me do this. You see my screen? Okay. So I'm still Ivan Fernandez, and I'm still a soil scientist. I put on the slide sort of three areas of activity that I would say fill up my life. As a soil scientist, I do a lot of work in that regard. A lot of it has to do with carbon. What you're looking at up here is we just published a paper like 6 weeks ago that evaluated the three major soil databases for Maine in order to determine the amount of carbon that they represent and how they differ for when you're on Jeopardy and you're asked what the state soil is. This is a picture of a Chesuncook, which is the Maine state soil. Don't take it lightly. It took me 2 sessions of the legislature in the 1990s to get Governor King to sign that into law. We're also doing work in soil amendments with biochar as part of some natural climate solutions work that's ongoing. And the second area that I spent a lot of my life on is mostly I'm a biogeochemist in ecosystems, particularly forest ecosystems. And these are pictures of long-term records. My colleague, Steve Norton, who I learned how to retire from, and has been involved with, I've been involved with him for many years in this long-term whole watershed manipulation experiment. I've been involved with several of those in the state of Maine, in Acadia National Park and Weymouth Point, having to do with different disturbances, fire. This was an acidification experiment as well as harvesting impacts. And then number 3 here is in the past year, certainly, and I've spent a fair amount of time in different contexts with US EPA and within the state of Maine. But in the past year, probably many of you are aware that there's a Maine Climate Council that the governor signed into law in 2019. And this past year has been the key year for that activity. There's an integrated climate action plan for the state, the first integrated climate action plan for the state, due to the governor and the legislature in December, and then every 4 years thereafter. And over the past year, what you're looking at here is there's 39 members on the council, and then there was about 230 plus people, a number of people in the Institute, and Sean and Joe and others that are perhaps on the call tonight, were involved in the work over this past year, coming up with a set of strategies that have been sort of delivered, as well as some modeling to the council, and the council is now busy working on essentially writing the plan that we'll see unfold. And if people are interested in, at the state level at least, watching science inform policy, to the extent that it does, and in many cases it is here in Maine, we're really living through a unique time, and between the convergence of COVID and the good timing of the state being launched into this climate action plan, there's a lot going on. And for those that are interested, I encourage you to check out the website, contact myself or some of my colleagues that are involved in that as well. So I'll stop there.
Thanks, Ivan. Next is Katie Glover.
All right, thanks so much. Let me get my screen set up to share. And as I mentioned in the intro, I've been at CCI since 2017 as a postdoc, now research associate, and I mentioned I'm instructor for various departments and classes. But broadly, what I focus on is the past glacial ecosystems in North America, especially the Mediterranean climate and flora of California. This includes a recent publication on a 100,000-year multi-proxy record in Southern California, and modeling past vegetation communities in the Los Angeles Basin during marine isotope stage 3. And this is an important time because this is when it served as habitat for Pleistocene megafauna found at the tar pits. Tonight, what I'd like to do is highlight some of the work I've been able to do with support from CCI and other departments at UMaine. I'm in the final weeks of wrapping up the first project I PI'd, which focused on paleo-environmental change in the Kankakee Marsh in Indiana. And this was a former wetland complex that used to be called the Everglades of the North because it was so extensive and biodiverse. National Geographic funded our attempt to core in the watershed for late Holocene material, but over half of my time and project resources have ended up going more towards undergrad mentorship and outreach for the project. That included supporting capstone projects, including one that was recently published in Wetlands last month, comparing soil properties between the dredged and the non-dredged areas in the marsh. And this summer I worked with School of Education and Ecology and Environmental Science undergrads to create curriculum on this area, the Kankakee Marsh. And these were aligned with state standards and earth processes like glaciation,
the students, and there's 4 of them, are in the process of posting their work to curriculum hubs like the Science Education Resource Center. So here's one. This was done by Mariah Whiteman, Earth Science student. And C3 Teachers is another hub we've used for social science, geography, and history. Finally, I've been working with WGS and Humanities to offer again my course, Women in Climate Change. So undergrads and grads are welcome to enroll for this spring. We hope to offer a speaker series as part of the course that would be open to the public and partner with the Story of Climate Change Symposium with the McGillicuddy Center this spring. And yeah, if anyone in CCI would like more info on that class, grads in particular, if you want to talk about Nat Geo's grant program, reach out to me. And I'm happy to talk to anyone about collaborating on K-12 outreach or undergrad mentoring or curriculum development as part of your broader impacts. Thanks.
Thanks, Katie. Next up is Roger Hook.
Out here. Okay, can you hear me?
Yes.
Okay. Was working on glaciers for about 30 years, about the first 15 years on Barnes Ice Cap on Baffin Island, and then 15 years on a small glacier in northern Sweden. And one of the products of that was a textbook on glaciology. I'm also a geomorphologist. Some of my best work has been on rivers. And just now I'm working on a couple of projects. One is a study of the human impacts that have developed since World War II, when it's been a time of what's been dubbed the Great Acceleration, when CO2 levels have gone up, GDP has gone up at incredible rates, extinctions have gone up at incredible rates, and just trying to draw attention to this and the impact it's having on the Earth and on our life support system. The other thing I'm working on, I'm kind of excited about, is a model using perturbation theory that seems to be showing that the absence of a MIS2 glacier advance in the high mountains of Tibet is not attributable to an arid climate, but rather to a decrease in the number of days, number of melt days during the summer as the climate cooled. So those are the things I'm interested in. I'd be happy to talk with any students that have questions about glaciology or geomorphology, and I'll stop there.
Thanks, Roger. All right, next up is Cindy Eisenhower.
Hey, everybody. Nice to see you again. How's the screen share? All right. Yeah, so again, I'm Cindy Eisenhower. I'm in the Climate Change Institute and also the Department of Anthropology, where I am a cultural anthropologist with a specialization in environmental and climate policy. From the broadest perspective, I am interested in systems of production, consumption, disposal, so stuff and all of the emissions that are embedded in all of that stuff that we cycle through our economy. I'm going to tell you just about one project tonight. I have 3 current research projects. This is one that's focused on the circular economy, and the idea there is that by circularizing our production and consumption systems, we can eliminate waste and also a lot of emissions and energy use along the way. This is one of the graphical representations of a circular economy produced by the Ellen MacArthur Foundation, which essentially separates the biological cycle from the technical cycle or the material cycle, and gives us kind of a roadmap for doing that. How it relates to my work with climate change is that many of you likely know that we have at the international level, a very significant, what we call mitigation gap between what the parties to the UN FCCC have proposed that they are willing to contribute to mitigation. So that's their nationally determined contributions. So we have a big gap between what we know we need to hit to reach a 1.5 degree or a 2 degree scenario and what they've promised. So in kind of following that, I've been tracing the development of policy at the international level and also discourse to understand how circular economy strategies are increasingly being used to try to close that emissions gap. I've noticed since starting to attend the meetings in 2017, a significant uptick in the amount of circular economy rhetoric and specific research proposal or policy proposals. Many of you may know that the EU has a fairly strong circular economy emphasis right now. So my research is really looking at the effects of those policies for mitigation and also their implications for global climate justice and equity. Thanks, everybody.
Thanks, Cindy. Next is Alice Kelly.
All right. And I hope that you can see my screen.
We can see your keyboard. Oh, there's your screen.
Right, yeah, okay. Not exactly flawless, but here we are. I'm Alice Kelly, as I said earlier. I'm at the School of Earth and Climate Sciences, and I am very pleased to be associated with the Department of Anthropology and the Climate Change Institute. My area of research is geoarchaeology, and I split that into two areas: human landscape interactions, as well as cultural heritage and climate change. The classic definition of geoarchaeology is using geological processes and techniques to answer archaeological questions, but I found in the few decades that I've been working in this area that it works the other way around. I started working with David Sanger, one of the early members of the Institute, and since then I've been pleased to work with Dan Sandweiss and Bonnie Newsom, who are in the Department of Anthropology and the Climate Change Institute. With Dan, I've been working in Peru on human landscape interactions. We've looked at changing environments. What you're looking at here are stark desert terrain, but we know that in earlier times, people were dealing with El Nino, the impact of El Nino in the form of a great deal of rainfall, as well as indications that in some parts of Peru on the coast, we had much more extensive wetlands or surface water than we do today. And so we're exploring that in an NSF funded project right now, hopefully getting to Peru soon. Also at the site that you see on the screen is an area where we are looking at some of the potential earliest use of adobes with one of our former students and now prized colleague, Cecilia Mauricio from Lima at the Catholic University. Here in Maine, I've been working in cultural heritage and climate change through a citizen science project called the Midden Minders, where we are documenting and monitoring the erosion of coastal shell middens, or now more accurately referred to as shell heaps. We've done some work in that area using ground penetrating radar, and we use simple tools with our citizen scientists to monitor how these middens are changing in the face of climate change related sea level rise and increased storm frequency and freeze thaw events. And then also getting a bit more archaeological, looking at these shell heaps as monuments, not just trash dumps, but as purposely constructed features. So that's what I'm up to, and I welcome anyone who's interested in the same sorts of things and would like to talk. Thank you.
Thanks, Alice. Next is Peter Coons.
Right, the other participant has to unshare their screen. Thanks, Alice.
Ah, beg pardon. There you go.
Thanks. And with luck, we'll get through this. I think I have a cat behind me that's trying to help out. Okay, what I'm going to talk about mostly right now is some of what really occupies most of my time, and that's associated with fluid-solid dynamics. And the solids can range from things down to the mantle through to the atmosphere. And the examples that I'd like to look at today are ones which students, hang on, I'm going to throw this cat out the door. I'm going to turn that on and you can watch that video. I'll be right with you. Okay? That was cat as critic. Right, so in this particular case, we're looking at the interaction of solids and fluids. It happens to be something that was done in a course, and it was done predominantly by Ian Nesbitt, who's here, but also helped out by other students, Nick Whiteman, Lynn Kaluzinski, and Nick Richmond. But we're looking really at the airflow across the top of driven by katabatic winds, or modeled as such, and then coming out across the ocean area and generating a flux in the ocean and also affecting many other things. Another example that we're looking at is the physical controls on coastal permafrost that Seth mentioned earlier, and taking some of the work which Nick had done with several of us, but particularly with Joe Kelly. He had looked at the effect of waves on the shoreline, and then we took that and we are now thrown into mice, and Nick has now has put the waves associated with waves on the ice to look at the physical effect, not just of the waves themselves on the permafrost, but also the sea ice, which is caught up in the waves and bashed into the coast. These are computationally intensive, and we can do them now because of some of the new hardware that we have. Another example that we're looking at is particularly some of the interaction with habitat evolution, and this happens to be some work done by Nick Richmond and looking at the effect of a boom island on flow around the boom island, and therefore on the forces and velocities and whether the habitat is suitable, in this case predominantly for Atlantic salmon. We then carry that beyond for a student who is Mark Jordan, who introduced himself earlier. I should point out that Mark was also a member of the Quaternary Institute back in the late 70s. He's right there in this photograph. And then we then model the forces and flows by allowing a water to flow over the model bed, and that as the water goes, we can actually check to see what it does to any of it changes the habitat and what habitat can be engineered to enhance its, let's say, salmon habitat. And finally, since we could take we can model air, and we can model on a very large scale, that we thought that perhaps we could take a look at the airflow associated with COVID and make predictions about aerosol transmission. And Nick Whiteman, particularly along with Ian, has been looking at this. And in this particular case, we're taking a poor canary walking through a hallway about the size of the hallways in Bryan, and those curls that you see, or the eddies that you see around them, are the disturbance associated with the canary or a person walking down through that corridor. In addition, we can allow the person to speak or shout or play an instrument or open a window, and this we hope will actually sort of revolutionize some of the understanding of internal airflow. And there's other things, but that's where we'll stop now, and be pleased to welcome anyone into the world of fluid-solid dynamics at some point.
Thanks, Peter. Next up is Andrei Kurbatov.
Thank you, Dan. I'll talk in the next couple of minutes about my work at CCI with my collaborators. I have to mention that a lot of students were involved in these projects, and you can see most up-to-date information on my website at the Institute with my CV, where all projects and publications, papers are listed. I have to mention that I'm also affiliated with School of Earth and Climate Sciences, and I'm teaching there geohazards, and I've been developing now field methods class. So many of you probably will hear from me. I will be begging for some help on field sites in Maine, and maybe look for new technology and kind of good ways to get engaged students early in our exciting field of earth sciences. I came to Maine in 2001 to work on deep ice cores in Antarctica. It was Dome, and my goal was to basically look for tiny particles. It took another ice core, West Divide, and finally now we're working on a South Pole ice cores. And we finally, I think, figure out the way to actually capture and measure these ultra-fine particles from tropical eruptions. So people were doing it for years, but seems like we finally got it under control, and it's actually only in Maine, basically. We have this technology right now, and I'm pretty proud of it. And the idea is we can actually measure this composition of these particles, the shape, and see where they're coming from. And a lot of papers we already have, or we're involved in some papers that demonstrated that past assumptions that people have on the sources of these events are not quite correct. What it means really is that this volcanic forcing that people use in the climate models not completely well parameterized. Parameterization is not well done yet. So that's kind of an interesting angle. And my main collaborators here is Marty Yates, he runs Microprobe, and Neil Dunbar, Niels Iverson. We work from New Mexico Tech for years together. And recently, we just got funded with Carl Kreutz, Don Winsky. We're gonna look for the Stefan Denali ice core. So we're kind of spreading out to Northern Hemisphere. And another project I have with Stefra business is related to standardization of this kind of data collections. So people involved from USGS, it's Christy Vallis from Alaska Volcano Observatory. It's also Steve Kuhn from Concord University, and my PhD advisor, Marcus Borsig, who just retired from Buffalo. So it's kind of activity we're doing. We're trying to basically help people collect the data, better collect data. Another project I have with Paul Majewski and Princeton, we work on deep ice, old ice in Allen Hills. And this project is really interesting because we found oldest ice on Earth. It's 3 million years old ice almost. And also the work you will hear probably from other members here about our work in Swiss Alps using this laser ablation technology. That's quite interesting. And we just got funded also with Joe Talgeher from University of Minnesota to actually use lasers to drill ice cores. That's a new exciting development because it's kind of this kind of Star Wars age technology that we're gonna use to drill ice cores. And finally, I work with Chow and Sean and a couple of other people from US ice core community. Again, we're trying to kind of look how people collect data from ice cores and what they're actually doing with this. Again, this is kind of never ending project, but hopefully experience that Chow has from computer end of things in our experience with ice cores will help to really make it easy for people, especially for new investigators, because suddenly it's become like an issue when new investigators come to ice coring business that's quite complicated. So we hopefully will develop better technology. And I'll stop here again. I will reference my website that you can go and take a look for more details. And thank you.
Thanks, Andre. Next up, Kirk Marsh.
All right. So normally this week I would be in Boulder, Colorado instead of in Maine, but because the world is different, as Paul was describing earlier, I'm here. But for the last 2 days, I got the pleasure of going to the UCAR members meeting on Zoom. And I'd like to share with you a couple of the things that you might be interested in that happened at the meeting. There were a couple of bylaws that were changed. Paul will be happy to know that one of them now allows to a member rep, which I'm the member rep and Paul's the other member rep for UCAR, can be substituted without getting a letter signed by the president of the university. Now it can be signed by the department head or the director. So we'll be able to swap you out, Paul, in the future if you don't want to go to meetings when they come back in person again. But there's some things that might be of interest to everybody that will come out of this. There were some question and answer sessions of interest that went over some of the key programs at UCAR and at NCAR that have a bearing on a lot of the research that we do here at the University of Maine, things you would be interested in. There were pre-recorded updates for the newest things at UCAR and at NCAR and UCP, which is the UCAR community programs, which have many aspects that are useful for not only our research, but for our teaching as well. And there was also some good updates on what's happening in Washington with budgets as it relates to funding of science across all the funding agencies, and in particular the National Science Foundation. There were also some really good breakout sessions where program managers summarized what's going on and what is going to happen in the future. Many of you already know what you need to from your own program managers and things of that sort, but the overview for the students and for those who want a refresher or want to know what's the newest would be good to look at. And so what I have listed here are the highlights, and they are recorded updates already, and these sessions and the breakout sessions will be available to look at. Not that we don't already look at a million things on YouTube already, but I'll make available to everybody the links to these when they come out. In particular, the program manager breakout sessions covered these areas that are listed here. I won't read it. The other thing that was really of interest that would be a big help, as I said, for our research and for our teaching, available resources, were the UCAR community programs breakout sessions that were also recorded and will become available. And I'll forward the information to everybody once the links are hot and that they're ready to look at. COMET, if you don't know, is a vast array of thousands and thousands of resources that we can use in our teaching for atmospheric and related sciences. There's a ton of stuff there. They had a good session on broader impacts requirements, and those are getting a little more difficult to write sometimes because the same old doesn't always fly. In program managers' eyes, you can't just say, I'm going to have some graduate students and that's my broader impacts. It doesn't work like that anymore, as you probably all know. And so they have resources at UCP, and also people who are willing to work with you if you reach out to them to help you to make yours better. In terms of data, Unidata is one of the world leaders in serving up data and managing it and making it accessible. And this will teach you some things that you can use in your work in terms of cloud computing and a whole bunch of other analysis and visualization ways that things happen now. And then for those of you who are interested in the vertical profile on the atmosphere, the COSMIC 2 array of satellites, which was launched within the last year, is up and operational and provides several thousand vertical profiles of Earth's atmosphere every single day. So if those things are of importance to you, it would be good for you to know about that. In terms of my recent projects, I tied up, well, along with Susan Elias, a student who got her PhD last year. 3 papers have come out since then. Well, actually 5, but I was a co-author on 3 of them, about our tick-borne disease spread and how it connects with climate change. And also, I've been having a lot of fun with Dan Sandweiss, working on shells and El Nino and all that kind of good stuff. And I think Dan will probably say some things about that when he gets to go. So that's an update from UCAR stuff. And again, I'll make available with a post. I'll probably just put it in a PDF with hot links and send it around to everybody so you can get at that stuff and make use of it. So that's good.
Thanks, Kirk. All right, next is Paul Majewski. Paul.
Okay. Okay, thank you, Dan. So despite my 100% appointment in the Climate Change Institute, and because I'm extremely interested in interdisciplinary studies, I'm also affiliated with Earth and Climate Sciences, Marine Sciences, Policy and International Affairs, the Business School, and the School of Law. And I couldn't do all of the things that I do with all of these people. I won't name them because of time, but thank you to all of you. For the last couple of years, I've been heavily involved in several different projects. One of them is a joint project with Harvard History Program, in which we have recovered and analyzed the most detailed ice core record ever collected in the world. We have millions of data points. And one of the things that we are most interested in is looking at climate change and how it relates to pandemics and how pandemics relate to changes in the economy. We're in the process of going back 4,000 years now. I've also been working on various water towers throughout the world, Peru, Bolivia, and Chile, to try to understand how water availability and water quality has changed over time. We will be going back to Kelkaya ice cap. We hope in the next few months. It was postponed in order to translate that ice core into the highest resolution ice core in the world. I'm still continuing the work that I did with GISP2. There's the pointer for our logo, in which we discovered abrupt climate change. And we know that the Arctic, it has changed dramatically recently, and as a consequence is having impact throughout the Northern Hemisphere. I was approached by National Geographic to lead the Everest Expedition 2019, in which we produced a whole series of multidisciplinary studies, including the highest ice core in the world collected by Mario Podolsky of our institute, plus also the two highest weather stations in the world. We've been working in the Southern Ocean on climate change as part of a long-term program of 21 countries that I organized and still continue to work with, focused primarily on climate change, water quality, and food availability, because Southern Ocean is so important. Been working with Andre on the oldest ice in Antarctica to try to understand how orbital cycles, in fact, may have changed in control of climate. I'm heavily involved in climate prediction programs in Maine, Asia, the Southern Hemisphere, and Greenland. And in addition, I've been doing a lot of public outreach through presentations and also a whole new series of papers coming out in places such as the Geneva Press, Global Geneva, in which Charles Norkey and I published our work on COVID-19 and climate change. Thank you.
Well timed. Thank you, Paul. All right, next is Alessandro Marighetti speaking for Jacqueline Gill.
Yes. Can you all see my slides? Okay, so hi everyone. Jacqueline Gill, my advisor, is on sabbatical this semester. So I'll just give a brief overview of the lab. And the name of the lab is the BEAST Lab, Biodiversity and Environment Across Space and Time, because what we do is trying to understand the relationship between climate change and biodiversity patterns at different scales. And to do so, we have ongoing projects in the Falkland Islands, where Jacqueline and her students were looking at changes in the local winds and how climate change affected the colonies of seabirds. We are looking at Siberia and Alaska to understand what was the effect of the extinction of Arctic megafauna on vegetation there. And other people are working also in Maine to understand what the past plant communities were, how they were reacting to climate change, what is the possibility to have climate refugia, for example, in Acadia or in Baxter. And to do so, we use a set of different tools and proxies. So the question we try to answer are all related to how biodiversity change with global change. And the main things we are interested in knowing is like, what is the legacy of biological upheavals on ecosystems? For example, how did the extinction of large herbivores in Beringia affected the tundra at the time? And another thing that Jacqueline is about to start working on is funded by a NASA grant, is like why fern were so successful after the late Cretaceous extinction event. Then we want to know how can paleoecology inform conservation, because we can learn from the past and try to inform the future, because like climate change right now is mainly an anthropogenic thing, but climate change in the past, and there's a lot that we can learn that can maybe help us to shape a better world and adapt for the future. Then we're interested in understanding how climate change change the shape of biotic interactions. Is competition going to be a major factor in the future under the pressure of anthropogenic climate change, or other things are going to become increasingly important, like facilitation? And another outstanding question we have is like, what is the effect of first human arrival on the ecology of islands? And this is something that Jacqueline and her students are doing in the Falklands. And to investigate this, we use an array of different tools and techniques. Again, like sediment cores, where we look for pollen and charcoal to reconstruct in tandem changes in fire regimes and vegetation. We are now expanding to be able to use ancient DNA from sediment cores and coprolites and gut contents from carcasses of animals from the last glacial period. And we are really open as a lab to interdisciplinary work. So Jacqueline is not, she's in a sabbatical, but she calls it like a stay-batical, because like she's around and open to receive any inquiry via email if anyone is interested in doing some kind of work with us. Thank you.
Thanks, Alessandro. You do a very good Jacqueline. All right, next up is Kimberly Miner.
All right, I am figuring out how to share my desktop. Okay, it looks like I am on a computer that won't let me share, unfortunately. So I'm going to just give you a little talk rundown. So my name is Kimberly Miner. I'm a research assistant professor at CCI. Super excited to see everyone. My main hat is I'm a scientist at NASA's Jet Propulsion Lab in Pasadena, and I work on the Arctic Methane Project with the Above team, the Arctic Boreal Overview team. And I wanted to talk a little bit about all the different things that I could potentially help students with, and that's what my slides were geared towards. But I'm also a AAAS If Then ambassador, which is a group of 125 scientists doing outreach on different topics. So I'm happy to chat with anybody about different kinds of science outreach, especially climate change outreach, which can be a little bit tricky. I also was raised up through the Carl Kreutz lab, so I have a specialty in Arctic and in emissions of pollutants and the impacts on humans. So climate change risk assessment is kind of how we encapsulate that idea, and I'm happy to chat with folks about abrupt climate change in general, but then the more legacy and long-term impacts in specific. I'm sorry that I wasn't able to get the slides to work. There are some, this is a NASA computer, so there's some handles on it, but if anyone is interested in talking more, I am available. I'm in DC right now. We'll be moving to California eventually, but I am around by Zoom and would love to chat with students. All right, thanks.
Thanks, Kimberly. All right, next up is Alex Moore. I think you're muted.
I've done this twice today. I've talked to myself for 10 minutes the last time. Paul already mentioned our collaboration with Harvard, the Initiative for a Science Human Past. Where I was in fact educated and got my PhD, I have curated a geodatabase of all written records, what was called earlier climate history, of all weather observations for the last 2,000 years, the largest such database on the planet. It looks a lot like the COVID map from Johns Hopkins University. We can select by various codes and map them out on the screen, and then get data sets from it. We can also map out pandemics based on historical data and compare those with climate data. And we're in the process of actually interfacing these with Climate Reanalyzer with Sean's amazing help. And I also just recently, can you see the Chrome Washington Post? Or if I share just, let's just share it again. We recently published an article that went to the AGU GeoHealth new journal. It's called The Impact of a 6-Year Climate Anomaly on the Spanish Flu Pandemic in World War I. We showed that with our high resolution climate record from Cologny-Fetti that Paul was mentioning, we found a once in a century climate anomaly that showed a weather anomaly, climate anomaly of 6 years that brought wet and cold air over Europe for the duration of the World War, as well as the Spanish flu pandemic. And comparing that with mortality record, we saw that there was an association between mortality and precipitation. Of course, everybody loved this, including CNN and the Washington Post and Stars and Stripes, which I find fun, and Newsweek and many others. And so that's been also part of my job, communications and outreach. I do quite a bit of it for our initiative, for CCI as well. Yeah, so I'm at the convergence of the two crises, pandemic and climate change, and I use all data that's available to me to explain both.
Thanks, Alex.
Yeah.
Bonnie Newsom is next.
Hello, everyone. It's good to see you all. My name is Bonnie Newsom. I'm an archaeologist specializing in pre-contact lifeways of the indigenous peoples of Maine and the Maritimes, and I focus heavily on shell-bearing sites along the Maine coast. I work very closely with Alice on shell heaps and protection of those spaces. I also work very closely with indigenous communities in Maine. Often I center my research on the agendas and values of indigenous peoples. And my research is somewhat eclectic, and I thought I'd share some highlights of a few projects I'm working on. I'm currently involved in a sea mink study with colleagues from several other institutions and the Passamaquoddy tribe, and sea mink are extinct, and this project uses specimens from Maine sites to determine whether the sea mink is a unique species genetically, whether or not the sea mink was a specialist on marine food resources, and if the sea mink was interacted with in different ways by different groups of people over time. And we're also looking at how it compares to the American mink as well. A second project I'm involved in is a collaboration with Acadia National Park. 2 graduate students and I are revisiting old collections from sites on Isle of Ho and Fraser Point in order to understand the cultural significance of these sites. These data will serve as the basis for tribal community engagement with the 4 tribes in Maine, and will help to serve will help park officials and tribal communities make management decisions about shell-bearing sites located along the coast and in the park. Finally, my specialty is actually archaeological ceramics, and I always have a ceramics study underway or in the works. Recently, I conducted a technological comparison of ceramics from the Penobscot River Valley, some of the first ceramics in Maine. And part of this study involved analyzing ceramics from the Hirundo site, which was excavated in the 1970s. And interestingly, the Hirundo Archaeological Project was one of the first interdisciplinary projects involving early faculty from the Institute. Hal Borns was involved in that, as was my advisor, Dave Sanger and Ron Davis. And so these collections are still available. And as a side note, the Northeast Archaeology Lab, which I manage, has lots of these legacy collections from decades of archaeological research at the University of Maine. And these often include soil samples, shells, and other archaeological and paleo-environmental data sets. So if anybody's interested in accessing some of those, please get in touch with me. So thank you.
Thanks, Bonnie. Next is Steve Norton.
Whoops. I am live. Can people hear me all right?
Yep.
Okay. Many of the grad students don't know what I look like, except they might have looked at me earlier, but this is a picture of me about 12 years ago in Acadia National Park processing a core. I don't wear glasses anymore because of the miracle of modern science, and I lost that hat, but I still have that coat. But basically, in the lower left-hand panel are the spots that I have been working on for the last 50 years now, starting with fog chemistry and cloud chemistry, precipitation, and then following water along the hydrologic pathways into lakes and streams and wetlands as well, and then out to the ocean where I've never worked. But I've spent a lot of my time looking at lake sediments and bog sediments, partly to reconstruct atmospheric deposition of pollutants and partly now to unravel longer term processes that are unrelated to humans. I put out a plea that if anybody's working in paleolimnology, that I'd be glad to talk to you. I've had a lot of experience coring about 60 lakes from the Sierra Nevada to Maine, and then from Svalbard, north of Norway, down to as far as the Czech Republic, and done a lot of lead-210 age dating and chemistry and speciation of metals within sediments. And I'm particularly interested in the interactions of geologic materials and water, aquatic systems, and studying natural processes as well as the anthropogenic ones. But I've worked on chemistry of precipitation, soil, streams, lakes, lake sediment, including road salt, fertilizer, metal pollution from the atmospheric deposition, acidification of atmospheric deposition, and recovery from these stresses. I've also been involved in short and long-term chemical manipulation of entire ecosystems, the most prominent of which Ivan Fernandez mentioned earlier, Bear Brook watershed. That's been under study now for over 30 years. It started out as a 10-year program with EPA and ended up with NSF and local support from USDA. And lastly, in the last few years, I've been worried about sensitivity of modern lake systems to physical climate change, in particular temperature. The most recent thing that I'm trying to unravel now is I've done the rare earth elements and major chemistry and phosphorus aluminum relationships in 2 lakes, starting with deglaciation right up to the present. One is Plesnia Lake in the Czech Republic, and the other one is Sargent Mountain Pond at the top of Sargent Mountain in Acadia National Park. And I just leave you with this one panel to think about, and I'm trying to unravel why the lead 207-206 ratio, they're both radiogenic in origin, why starting at the bottom of the core in Czech Republic, and I didn't have time to get the ages on here the last few days, but they're almost comparable in age. Starting at deglaciation, that ratio dropped precipitously right through the Younger Dryas, which is right around 280 centimeters down in the core, and then started to recover. And now the last data point is up here, which is anthropogenic lead coming in from basically tetraethyl lead in gasoline and smelting and coal burning. Sargent Mountain Pond, in contrast, shows virtually no trend after about, well, the Younger Dryas is right about here, and there's no trend there. And the solution has got to lie in the mineralogy of the two watersheds. One is underlain by granodiorite, and the other one, Sergeant Mountain Pond, is just a good, healthy granite. And the weathering processes that are selectively removing the more soluble minerals through time, giving rise to this trend here. So next year, if I'm still around and kicking, I'll tell you what the answer to this puzzle was. Why does one lake not change really very much at all over 16,000 years, and the other one goes through this wonderful trend, which is not totally understood. I can only hypothesize what's going on. I put in a plea for George Jacobson, who's not listening now, and myself and Roger Hook and other people who are retired. We're here to help, and we're still doing active research, and we look forward to Zoom meetings with you, but more importantly, eventually we will break out of all this and we'll be able to get together in my office, which is in 314 Bryant. Thank you.
Thanks, Steve. Next up is Aaron Putnam. Is Aaron here? All right, assuming that Aaron is not here, then next up is one of my closest colleagues, which is me. And there we go. All right, so I'm Dan Sandweiss, which you probably know by now, and I'm a professor in anthropology and the Climate Change Institute. I also am cooperating at Earth and Climate Sciences and in global studies. And if you haven't figured this out yet, I am a resident punter in the Institute. I do various things. Much of my research is about climate and culture in ancient Peru, mainly on the coast. And I don't do this alone. I work closely with Kirk Marsh and Alice Kelly, but over the years, many of my colleagues from the Institute have come to Peru and contributed to the research in important ways. The first was Rick Faulkner, who some of you may remember, Dan Belknap, Hal Borns, Dave Sanger, Marty Yates, Joe Kelly, and most recently, also Jim Roscoe. So it's one of the privileges of being here at the University of Maine and in the Institute that I have so many colleagues with such expertise willing to contribute to the research and collaborate together. I particularly work on El Nino. Those of you who speak Spanish know that El Nino means the child. But for the rest, it's a climate phenomenon, and we try to track its change through time using remains from archaeological sites as a kind of climate archive. And then we try to look at what that meant for people who lived along the coast of Peru throughout the span of prehistory and into the present. Another thing that I do is to study ancient maritime adaptations. It may sound fishy, but it actually is very important, both for understanding people, but also this is where we get a lot of our climate data out of archaeological sites about El Nino. It's from fish and shellfish remains. Finally, I do a lot trying to bring together archaeologists of the two continents in the Americas, particularly South America and North America. I do this through founding a journal, founding a conference series. I've been on and led many committees for the Society for American Archaeology related to these issues, and I run a listserv to provide information for people who do archaeology in the Andes. And now, trying to follow my own advice to stick to 2 minutes, I will. And now, next up is Jasmine Soros.
She had to leave early, so I think she had a family issue.
Okay, then next up is Kristen Schild.
All right, share my screen here. All right, given that we're already over time, I'll make it pretty quick. So I'm Kristen Schild. I'm a research assistant professor here within CCI and the School of Earth and Climate Sciences. Broadly speaking, I study the interaction or the interface between glaciers and bedrock and oceans. Some of my big questions that I ask have to do with how quickly glaciers are moving, what are the drivers, how the ocean is contributing or impacting pretty much any place where ice and water come into play with each other. So either underneath the glacier, through the glacier, at the terminus of the glacier. Those are a lot of the questions I ask. And I study these in a lot of different ways. So this study was in Patagonia, and we installed some time-lapse cameras out there. I also look at a lot of satellite data, quite a lot of just big data sets in general, but we go out, we collect measurements in boats, we collect them through GPS on the glaciers, sometimes even GPS on the icebergs themselves. I used a lot of different technology to try to study this environment and see how it's changing. And one of my recent projects was actually looking at icebergs. And so we took some measurements below the surface using sonar, and then above using drones to fit these icebergs together to get these 3D models that we scanned multiple times so we could actually get at the melt rate and the mass loss with depth. And so now we're trying to constrain some of these ocean models that are trying to quantify ice melt and how quickly these are deteriorating because of their impact on global ocean circulation. So those are just some of the projects that I work on, both in the Arctic, up in Greenland, Svalbard, and now in Patagonia. So, oh, and I also am the coordinator for UMaine Arctic. So if you have any interest in any of the Arctic events on campus, I can also talk with you about that.
Thanks, Kristen. All right, next is Dominic Winsky.
Hi, everyone. Thank you for everyone's talk so far. It's been really great to hear from you all. And also thanks to all of you new students for joining the Institute. I really look forward to meeting all of you, and please don't hesitate to get in touch with me or anyone else that, or if our research sounds interesting. So I am a research assistant professor jointly appointed between the Climate Change Institute and School of Earth and Climate Sciences. I also teach in ecology and environmental sciences, and I study the interaction between the cryosphere and glaciers, as well as the physical and atmospheric climate system. And I'm particularly interested in how regional climate changes in response to global scale forcing, because regional climate is what we all ultimately care about, being people who live in a specific area. To investigate these problems, I primarily use ice cores as paleoproxy evidence of past climate change, alongside modern instrumental modeled and reanalysis data sets. I've got a number of active projects going on, which are listed here. I work a lot in the north part of the Pacific Basin, in the alpine areas in Alaska and the Yukon. I'm also looking at climate wildfire interactions in the same area, as well as Antarctic proxies, primarily of sea ice. I also grew up in Maine, so I work a lot, especially in Washington County, where I grew up, which is the poorest county in Maine, and also very much tied with the primary resource sector, and is hence very vulnerable to any climate changes that we'll experience. So I work closely with a number of folks in that area on conservation and education projects, which are ultimately inextricably linked from any discussion of climate change. So for all of those of you who are new graduate students, please don't hesitate to reach out to me if any of these projects sound interesting. I really look forward to meeting all of you. Thanks.
Thanks, Dom. All right, next is Greg Zaro.
Okay, does that work? Hello, everybody. My name is Greg Zaro. I'm an associate professor of anthropology and climate change, and I'm currently the chair of anthropology and of modern languages and classics. So I wear a few different hats right now. My interest in archaeology is long-term is understanding the process of urbanization and landscape change and the intersection of people, climate, and the emergence and evolution of cityscapes. So naturally, my work is focused on the last 3,000 years or so. Historically, it's been in Belize and some in Peru, but more recently, I would say over the last 7 years, I've focused on the Eastern Adriatic region in Croatia. where we have a project at the Nadine site, which is just inland from the city of Zadar on the coast here. And Nadine is a 3,000-year-old hill fort settlement, which is what we needed when we first went into this project. It's collaborative with my colleagues at the University of Zadar. So we needed a long-term record, and we want to look at this intersection between people, climate, and environment through time, and how this shapes landscapes that we see around us today. So there's the hill fort here. Our excavation has been focused here for the last few years. It's about 10 by 35 meters in area, but we've done some sample testing around the site a bit. Naturally, within a project like this, there's a lot of subplots. And so I'm just going to share a couple of quick ones with you that we're working on right now. Something recently published is looking at the early modern era landscape. So basically 14th through the 17th or 18th centuries. We identified a mosque at the site, a remnant from the Ottoman occupation of the region. It doesn't look like much here, but we're very confident that this is a 16th century mosque, and it probably looked somewhat similar to this one still standing in Bosnia today, which is also a 16th century mosque. We are trying to understand better this process of urban change, particularly from the Iron Age, which is demonstrated with the blue stripe here, basically the first millennium BCE, in this transition into Roman occupation when the site became a formal Roman municipium. It continued to evolve into late antiquity and was abandoned as the onset of the Middle Ages began. So there's a lot to play around with in terms of understanding urban change in this time period, but looking at continuity and discontinuity of city planning and built infrastructure, and knowing that this is generally an indigenous Liburnian townscape that is evolving into a new imperial Roman culture. So we're interested in a lot of those kinds of questions. We have an over 5 meters in depth of deposits. So it's a lot of labor, a lot of time, a lot of people involved in this. Lastly, we're employing or looking at the archaeobotanical record, which is historically isn't employed a lot in research projects in archaeology in Croatia in particular. So this is kind of new for the region, and we're exploring some interesting observations so far, one of which is that olives really start appearing with Roman expansion into the region around the end of the first millennium BCE, which is a bit of a surprise given that olives are somewhat native to the region. And so we're trying to sort out how has maybe the expansion of a Roman economy or market economy impacted local cultivation of olives, and maybe alteration of the local landscape or regional landscape. Certainly they're probably importing oil to some extent, but these are all kinds of questions we're trying to sort out in terms of understanding the role people have played in shaping what we see today, going back several thousand years. Thank you.
Thanks, Greg. Are there any faculty members or postdocs who'd like to speak whom we have missed? Okay, not hearing anybody. I want to thank everybody. I just want to repeat something that Dom and others said. Particularly this is for students. If you have heard about some research or a method or approach to understanding things, a technique that might be useful or interesting to you, come talk to whoever spoke about that. We are a very collaborative group of people. We're here to do new things by putting new things together in new ways. And we are all on the Climate Change Institute's website. You can find us, you can get emails, you can get phone numbers, whatever you need to contact us. So please do reach out. Thank you all and have a good night.
Take care. Thank you.
Bye, everybody. Thanks.
Bye, everybody.
Bye, everyone. Nice to see you.